Great. Hello, everyone. Welcome to a special guest webinar hosted by the Cloud Standards Customer Council. My name is Tracy Berardi, and I am Program Manager of the CSCC. Thanks so much for joining us today. In this webinar, we will learn about the Cloud Foundry project. Cloud Foundry is an open source cloud platform as a service on which developers can build, deploy, run, and scale applications on both public and private cloud models. We're joined by the Cloud Foundry CTO, Mr. Chip Childers, and IBM's lead on Cloud Foundry, Mr. Michael Fraenkel. Chip and Michael will give us an overview of the technical benefits of using Cloud Foundry, and we'll discuss where the project is headed. If you'd like to download the presentation file, there's a link. It's right in the chat box in the GoToWebinar toolbar. We did just add one slide a few minutes ago. So that link, what we'll do is we'll update the presentation file right after the webinar. So if you want to check back, that will be available. And also following the presentation, we post both the PDF and a recording. It's up on the CSCC website, our events calendar. So if you go there, you can access this material as well. So at the end of the presentation, we should have some time for Q&A. We'd love your questions. To pose a question, you can do this at any time. Just put it into the chat box. And with that introduction, I'll turn it over to you, Chip, to get started. Thank you so much.
Thank you, Tracy. Appreciate it, and thank you, everyone, for attending. We hope this is useful for those of you that are interested in learning more about Cloud Foundry and its current trajectory, both in terms of adoption as well as the roadmap itself. So if we go to the next slide. So just a little bit of an update on the foundation itself and the Cloud Foundry community as it's grown. The foundation was officially formed in a legal sense in January of 2015. And it started off with a fairly robust member companies. Yet we've seen a significant growth rate as we've grown to, at this point, actually over 63 members. Approximately every 2 weeks we're adding a new member, and these are wonderful combinations of companies that are on the technology vendor side of the market, but just as importantly, a lot of users of Cloud Foundry are joining the foundation to help sustain it long term. Next slide. The project itself is actually a very complex distributed system that's brought together by all of these various project teams into coordinated releases. So we've got a large number of specific modular microservices that form the overall platform. It's over 185 discrete projects. There are significant increases in week-over-week code commits coming into the project itself, both from committers that are working on the project full-time as well as from members of the community that are participating and helping with bug fixes and additional feature work. Next slide. But besides the software itself, and we'll of course talk a lot about the features and where the technology is going, but the most important indication of Cloud Foundry's value to the IT community is in fact measuring the growth in the user community. There's over 173 meetup groups globally, with more than 33,000 individual members across 105 cities in 48 countries and 6 continents. So Cloud Foundry really has gone from a platform that saw some early adoption to now really a global phenomenon. We're seeing it show up all over the world. Next slide. I also mentioned that we have a lot of contributions coming in from the community at large, but it really does require a bit of a hat tip to those members of our community that are working full-time on the project. That's one of the things that's very important about the way Cloud Foundry itself is developed. We have a program that's called the Cloud Foundry Dojo program that's designed to be a clear path for someone who's willing to commit to being a full-time committer on the project, that's going to work off of backlogs, that's going to do paired programming with other members of the project teams. brings them into the project and sets them up to be successful in the long term. We've actually brought more than 30 engineers from 9 companies through this process. And at any point in time, we've got over 130 full-time committers working on the project. That means people that are working more than 75% of the work week, just focused on progressing the Cloud Foundry technology. Next slide. This is the current foundation membership. It's a pretty amazing group. Of course, you see a lot of the usual suspects in terms of the various IT vendors that are offering Cloud Foundry or that are providing services that wrap around it or tie into it. But we love to point out the users that are here. We recently announced companies like Allstate as well as Volkswagen have joined us. We have organizations like BNY Mellon, Bloomberg, JP Morgan Chase, Citigroup. These are all users of the Cloud Foundry platform that are committed to helping support its long-term growth. In a lot of cases, they're vetting their business transformation process on the CS platform. They're hopeful that, and they know that Cloud Foundry can help them reinvent the way that they deliver software and allow them to go through the process of digital transformation. Next slide. So focusing on some users, and this is representative of how pervasive CS is becoming in various industry verticals. We have users in aerospace with companies like Lockheed Martin. On the IoT side, we have companies like GE, who offers the Predix platform. Honeywell is a user. Logos we don't have there include companies like Siemens and Bosch. CS is becoming very, very common as heavy industry begins to adopt software platforms to deliver a more connected experience for their devices. And the same thing's happening in the automotive industry with Daimler, Ford, Volkswagen. In fact, even Hertz is reinventing the process of renting a car using CF as the backbone for that. Healthcare, we have companies like Hospira, Humana, Kaiser Permanente. They're all going through that same transformation. Next slide. And of course, Cisco runs the entire WebEx platform on top of Cloud Foundry. Companies like Garmin and Philips are doing the same thing. In insurance, we've got a wonderful story around Allstate, who's definitely spent a lot of time thinking about how they fundamentally changed the technology delivery pipelines within their company. And they're training an enormous number of engineers on some of the best practices for how you work with platforms like Cloud Foundry to change your business, to speed up software delivery. Same thing with media and retail. Next. I did mention financial services quite a bit. Telecom's another area that's kind of worth highlighting here as well. Telecommunications companies around the world are offering Cloud Foundry as a service to their end customers. This really speaks to the fact that Cloud Foundry is a great platform, not just for the enterprise to adopt, whether you're buying it from a vendor, whether you're adopting it by using the upstream open source technology directly, but there's really a robust market of service providers that are out there, and there's actually quite a few that aren't listed here that are offering as well. So you can go to your local telecom provider and ask them for an application platform. It's likely, depending on where you live, it's very likely that they have Cloud Foundry to offer you. Next slide. This slide, these 4 organizations, I think are, to me as an individual, the most important example of how Cloud Foundry is actually changing the way that software affects people, the way software affects individuals. What we're seeing is that the Cloud Foundry platform has been adopted by both by Australia, by the 18F organization within the United States government, the government digital service within the UK has adopted Cloud Foundry, as well as the NIA, which is the South Korean government. These 4 governments are kind of the tip of the spear. What they're focused on doing is finding the right platform and the right tools and the right people and processes to make the software experience for citizens completely different than it's been in the past. They're trying to reinvent the citizen engagement process. And Cloud Foundry is proving to be the appropriate platform for them as they try to drive that change throughout their countries. Next slide. So in December of 2015, we launched what is called the Cloud Foundry Certified PaaS program. And the intent here was to ensure that as a consumer of Cloud Foundry services or products or distributions, that you have a guarantee of some consistency for your CF experience between the various providers. So we launched back in December 2015 with 7 certified offerings that were based on Cloud Foundry. Pivotal Cloud Foundry, HPE Helion Cloud Foundry, SAP's HANA Cloud Platform, IBM's Bluemix in its 3 variants, whether it's the Bluemix multi-tenant, Bluemix dedicated, and Bluemix local. We also had Swisscom with their application cloud. Huawei offers the Fusion product line that they actually provide to telecom providers, local telecom providers in various markets. And then the CenturyLink has the App Cloud platform. And then just recently at the Cloud Foundry Summit, we announced 2 more, which is Atos is now distributing a version of Cloud Foundry that is called Atos Cloud Foundry. And GE Predicts also became a certified platform. So there's a lot of very interesting things that you can learn from this collection of companies and the collection of products. So the first thing I'd point to is that some of them are definitely horizontally applicable solutions. Others, like GE Predicts, while the core capabilities are absolutely consistent with the way the other distributions are operating, Predicts is designed around the industrial internet space very specifically. And of course, some of the other providers, including IBM and SAP, also focus on IoT workloads as one of their core tenets. SAP is another interesting distribution as well, because SAP software runs an enormous amount of the back office systems for enterprises globally. And what SAP is now doing is they're offering their software online as a service, and it's called SAP HANA Cloud Platform. And they're using Cloud Foundry as a way that they can provide both that multi-tenant experience, but also deploy the suite of SAP software onto public clouds, or they can deploy it on-prem in combination with OpenStack. And they're also exposing not just their software, but the same type of application platform support that everyone else is supporting. They're exposing that to the IT development team so that they can integrate custom applications with systems of record much more easily. So it's just a fascinating use case. Okay, next slide. I mentioned that we just had the Cloud Foundry Summit North America. It was actually an amazing success. It was last month. It was the largest gathering of Cloud Foundry, of the Cloud Foundry community in history. We had over 107 sessions of various types. We continue to grow the foundation. We also announced the new certified platforms, and we had a great support from over 29 sponsors of the event. It was really an amazing event. There were tons of user stories, users helping users, talking not just about the technology, about digital transformation. Next slide. We do have another summit upcoming this year, and that's going to be September 26th through the 28th in Frankfurt, Germany. We'd love anyone that's interested to please go take a look and register, or in fact, today, if you have an interest in speaking about Cloud Foundry, the CFP is still open for another week. You can go to cfsummit.com, and that'll redirect you to our summit site. Next slide. Okay, so that's enough about the foundation and some of the growth and trajectory. What we're going to do now is we're going to do 2 things. First, we're going to start by taking a look at the very simplified version of the Cloud Foundry architecture, just to ensure that everybody has context as we start talking about some of the new features that have recently been released or some of the work that's actually ongoing within the upstream project. So let's go to the next slide, please. You can see this is a very, very simple architectural diagram, but the idea is to set that context for you. Let's start at the bottom. Infrastructure. Cloud Foundry is a multi-cloud platform. It's designed to support any number of infrastructure choices. And actually, this list has grown considerably in the last 12 months. 12 months ago, Cloud Foundry was focused on supporting AWS, OpenStack, and vSphere. within the upstream project. But again, in the last 12 months, we've added support for Google Cloud Platform, Microsoft Azure, IBM software. Integration has been contributed by IBM. There's now a bare metal server provisioning system that can take the Cloud Foundry platform and deploy it directly onto servers in the data center without the need for virtualization or infrastructure as a service. So that's an incredibly important point to make, is that Cloud Foundry works across any type of cloud infrastructure, or can also be used just within a data center directly, landing onto servers. Now, going all the way to the top, the other point we'll make is that applications that are running on Cloud Foundry need to be accessible to end users of lots of different types. Of course, we have the normal web browsers and mobile devices. You know, this is where the normal HTTP-based traffic comes in. A lot of these applications are built as web applications. The overwhelming majority today of apps being deployed on CF are based on HTTP inbound protocols. But IoT-based devices is another area of significant interest, as well as significant effort in the roadmap, and we'll talk about this a little bit more. Now, within the Cloud Foundry platform itself, you can conceptually think of it as 3 different layers. There's the elastic runtime layer. This is the place that today stateless applications exist. These are the applications that the development teams are writing the code for. They're writing them in a way that hopefully follow as many of the 12 factors. If you're not familiar with the term 12 factors, it's worth looking at. It's 12factors.net. Those are best practices for how you create cloud-native applications. Now, below that, I've got a block called services. This is one of the strengths of Cloud Foundry. The CF platform has this notion of a service broker, which is a wonderful abstraction that's used to allow the owner of an application to select various back-end services that would tie into the app that they're about to deploy out of a marketplace. These are things like persistent storage, databases, message queues, cache clusters. Could be services that exist outside of the Cloud Foundry platform, whether they're provided by a SaaS offering or whether they're maybe provided by another cloud provider. Amazon RDS is a good example where you can actually broker in the RDS capabilities. And last, the services marketplace can in fact be a loopback to applications that are running within the elastic runtime. So if you imagine you create a microservice that solves for identity within your whole application architecture, you can have that identity service be exposed to the other application teams, and they can simply tie to it. The platform will allow applications to bind to it, and that's very useful. But last, last but absolutely not least, is there's a large amount of effort and time put into thinking about the operations of both the platform itself as well as the applications that are running on it. CF is designed not just for making it fast to deploy software, but also to guarantee that that software is going to be maintainable long-term, and that the system is going to take responsibility for ensuring the health and well-being of the apps that you've deployed to it. And so this is where things like the abstraction for how you deploy the platform itself onto various infrastructure options come into play. It's also where log aggregation occurs, and it's where health monitoring of both the CF platform itself as well as those applications lies. So that's the very rough overview. Let's now begin to talk a bit about some of the recent work that's occurred as well as some of the futures. So if we go to the next slide, we can skip this one too. All right. So those of you that have been following the Cloud Foundry project, or may have been following the Cloud Foundry project, you should be aware that there was work that was occurring very heavily for quite some time on a project that was codenamed Diego. Now, Diego is a bit of a pun. It's a pun because the nodes that would host the application instances in the Elastic Runtime layer used to be termed DEAs, Droplet Execution Agents. The Diego project did a couple of things, but the pun comes from the fact that the DEA architecture was rewritten from Ruby to Go, and so hence the DEA Go. Get it? All right. So That's the fun part. The importance of this rewrite is actually can't be overstated. The Dojo version of our elastic runtime layer is really a ground-up rewrite that is allowing us to align Cloud Foundry with some of the other emerging standards that exist in the open source world. And a prime example I'll give of that is that there's a layer inside of Dojo that's responsible for containerization of the apps that are pushed in, as well as running and managing those containers. There's the Open Container Initiative, which was seeded through some technology that the Docker provided to that Open Container Initiative called runc. And that's becoming really the default industry standard for how containers should be managed, what the runtime library should look like. And so the garden layer of Dojo is adopting that. It also, by rewriting our elastic runtime layer, we're also able to support directly running a Docker image that might be created externally to Cloud Foundry. So now CF can support both pushing code directly, letting the platform build and containerize that application, but it can also take containers that are being produced through some other pipeline process and run them within the same environment. You get most of the same benefits. The project, Dojo actually graduated from what's called incubation within the foundation to being a full active project, which means that it is considered right now parallel to the DEA and the Warden architecture. I will say that by the end of this year, we revision the Cloud Foundry Certified PaaS program every year. And so by the end of this year, the 2016 certs will expire, and everyone will recertify in 2017. And the use of Dojo will become the required runtime. Right now, there's a choice of an operator or a distributor between these two architectures. So it will become the required runtime. And then we'll be going through a sunsetting and end-of-life process for the DEA and Warden architecture. Last thing I'll point out to here with Dojo is that it's actually currently working towards what's called a 1.0 marker. Now, don't be confused. There are multiple companies today that are already distributing Dojo as the default architecture. It is absolutely being adopted within the enterprise and within the user base, and it's being commercialized by the vendors. But we have a target of scale. Within one cluster, we need to be able to target 250,000 application instances running in that cluster. Once we hit that point of scale, we'll actually consider the Dojo 1.0, in quotes, point to have been reached, and the project will continue to iterate and improve. Okay, next slide. So now we get into some futures. Dojo represented the rewrite of the elastic runtime, and now that we have a elastic runtime that's starting to adopt industry standards, we're now in a position to actually take advantage of some of the other communities that are built up around container platforms, container technologies, and we can bring some of those ecosystems together with the value of Cloud Foundry. So the first thing we'll talk about is persistence. In the real world, all of the goals of the 12-factor design pattern aren't always easy to actually be solved for. Right? There are applications that might require some type of file system-based persistence to be available to them. Now, today in the elastic runtime layer, you can't have that. It's everything that is the local disk is considered to be entirely ephemeral. The platform reserves the right to terminate instances, based on what the platform operator needs to have happen, as long as another instance is spun up on another cell. Your storage is just as ephemeral as the individual application instances that are running. So the persistence project is looking at how we combine the service broker model with the capability of attaching mount points to the containers that are running in the various cells and systems. So there's an example usage there, just to describe kind of the developer experience or the application owner experience. You push your application, and in this case, let's assume we're pushing WordPress. So you do a push of the WordPress code, you tell it not to start. The next thing you do is you do a create service, and the example service that's been published into the marketplace is based on Ceph, and you pick a plan, free, and then you name it WP Data. Third step, you do a CF bind service, which says now that I've created my service and pushed my app, I want to combine the two so that the persistent data store is available to the application, the WordPress application. That's what that binding step is. And then you start your WordPress app. Now that WordPress app, when it runs, even if it's just one instance or it could be hundreds of instances of WordPress, now has on every single app instance a mount point that is /app/WordPress/WP content. And that's where uploads into the WordPress platform typically are stored. So WordPress is always a fascinatingly overused example for kind of the hello world of app platforms. But hopefully this points to how the users will begin to experience persistent storage within the Elastic Runtime layer. Next slide. So then we get to networking. The common pattern for applications that are deployed into Cloud Foundry is to make these applications a microservices-based architecture. And if you understand microservices architectures, one of the key things that should come to mind is, well, microservices are in fact small, and they're intended to be a collection of services that, when all working together, form a full business application, or in fact might form multiple business applications. So the challenge we have today is that most of the communication that's occurring between these various microservices deployed into the system have to go out of the platform and then back down into the platform. And so that leads to some inefficiency in the network once you get to scale. It also makes it a little bit more difficult to have fine-grained access control and network policy between the various apps. And so we can improve that. We can make that a much better experience, both in terms of network utilization as well as in terms of the right abstractions for the application owners as they describe the policy for who can communicate with and who can communicate outside of the system. And so we're working today on a project to bring the notion of container-to-container networking, which perhaps is better phrased as application-to-application networking, into the system, policy-based, so that you can describe which other applications may have access to your application, or whether it's exposed externally. And we're working with an interface called CNI, or the Container Networking Interface. And a lot of different software-defined networking vendors have adopted that interface as a way to work with container platforms. So by adopting CNI, by building the basic constructs into the CF platform itself, we bring the world of SDN all the way up to the application owner in a way that lets them both work within the Cloud Foundry platform, but also potentially have a more seamless network experience across the heterogeneous data center if that SDN technology is spread beyond just the CF deployment. Next slide. I think at this point, Michael's going to explain some additional features for routing.
Right. So today what we have in Cloud Foundry is one way in, which is through HTTP and our routers. And one of the common requests being added is, how do I guarantee security, or how do I guarantee authentication, authorization, or other forms of checks on all requests that are coming into my application? Obviously, one answer would be, well, burn it into your application. And if an organization has many applications, having this requirement becomes a real burden on developers rather than having it be a burden on the platform itself. So one new feature that has been delivered most recently is the concept of route services, which is extending the concept of services, which are normally thought as something that's a back end to your application. But in this case, it's actually something that's a front end to your application. So in the diagram, I've identified in black and blue two different ways route services can be used. The first set are what you can consider as inline route services, where they sit in between the router and the load balancer, handling requests that are going to your application. So if we follow the black line, you can see that as a client makes a request and we hit the router that's there today, we will, in those cases where a route service is defined, we'll actually loop back around to the route service so that it can make further determinations and either accept the request and let it flow back through the system, back through the load balancer to the application, or it can reject the request right in line. And therefore, if you're doing authentication and it fails, or authorization and it fails, you can fail the request before it actually hits the application. A second form, which is shown in blue, is rather than have it be in line with the router and the load balancer, you can actually make it be the first entry point for your application. And so what would happen is when you bind a route service, it would expose an endpoint that your application or clients of your application should now use. And therefore what happens is clients go directly to the route service rather than to the normal endpoint for the application, and the route service will do the determination right there. Obviously, both ways are similar, yet the integration points are slightly different. And so we actually offer both options. Next slide, please. Another feature that was added was TCP routing. So as I've already mentioned previously, we have HTTP routing, but in order to support IoT as well as supporting other forms of protocols or other protocols like MQTT or other non-HTTP protocols that applications may utilize, we've now added support for TCP routing. And like our HTTP support, we want to make sure that this is scalable to support any number of applications. Obviously, with TCP routing, what the nuance is that instead of having all requests flow over a common port, which is port 80 or 443 for HTTPS, with TCP routing, you would actually acquire a port per application, or you can actually acquire multiple ports for applications. What this requires us to now also have is the concept of a router group to allow scalability across the ports. And what is being introduced later is the ability to have multiple router groups. So that way you can actually assign the same port to different applications. Obviously, if you think about it, within a given router group, we can only allocate a total of 64,000 ports. And if you have a large number of applications, those ports could quickly dry up. So by having additional router groups, you can now grow the set of 64,000 ports per pool infinitely. Next slide, please. Another feature that is actively being worked on and has been for the past year or so is the introduction of our V3 API. So most people really aren't aware of what version our API is at, but it's been at version 2 for quite some time. And the goals behind V3 are, one, that we're backward compatible, which is obviously key because we don't want anyone's scripts or processes to break as we introduce some of the V3 work. One thing that we've learned based on our usage of V2 or the customer usage of V2 is that there's a lot of intricacies and nuances with some of the APIs. And some of it is really just baked in as behavior behind the API. So as you start using the various forms, you get somewhat surprised or taken back by either the behavior or by the amount of work that's going on underneath the covers to return not just what you asked for, but far more than what you expected. And so with V3, part of the goal is to make the API discoverable and actually remove all the unexpected side effects or behaviors that came along for the ride. So what that means really is that the APIs will be more simplistic, but you'll actually get what you asked for and no more. Some other features that we've been pressed to fix is to be able to make the API faster itself. And this goes hand in hand with the previous concept. Because the API was doing more for you, it also introduced a lot of overhead. So by streamlining what it is it does, we can now actually make each API return faster. Now, what we've also done is, for those that are using Cloud Foundry, the most common operation used is pushing your application. Now, there is no construct called push when you look at the API. The concept of pushing your application is actually a sequence of 8 to 10 steps, depending, each with its own API behind it. The current concern is that when you're doing an update to your application, there's actually a long downtime, because part of this push sequence is that it first stops your app, goes through the whole sequence of staging your new application bits, or your binary, and then pushing that out and starting your new application. As part of the V3 rework, minimization of the downtime was key. And so what can happen now in the background is you can upload your application bits, you can actually stage them, and only when we need to actually switch from the old code to the new code do we actually have to take your current application out of service. Which means, most people will be happy with that. Now, there are already other ways that people overcome this with blue-green deploys or multiple versions of the application. But now versioning is also inherent with an application. What we've also done is we've made applications easier to manage. And what that entails is you can now provide a proc file which can identify multiple forms of your application. And what that would translate into is you always have what you have today, which is the web form, i.e. you get a web or HTTP access to your application. But you can also now identify additional tasks that are also packaged within your application. So you can easily envision having ways to construct the database or being able to view data within your database as additional tasks on your application that can be executed independent of starting your application. Along with that, as you see in the last item, we're providing the ability to execute tasks as well. And these are things that are really can be viewed as arbitrary commands that execute within the context of your application. So like we've shown before, where you may bind services, these tasks get all the environment variables and access to all the services that your application has started with. And lastly, we want to make sure that the API is more modular. And along with having the ability to version your application, if you've noticed that after you pushed a new version of your application, we've made it easier to roll back to the previous release. Or you can roll back to something before that as well. Today we'll be storing up to 5 versions of your application, so you can pick and choose as you roll forward or roll backwards. Next slide, please.
All right, so let's talk about Bosch. And we didn't really mention Bosch explicitly when we talked about that high-level architecture. But let me explain what Bosch is. Bosch is the distributed systems release engineering platform that can be used to deploy Cloud Foundry. It's in fact the way that the Cloud Foundry platform itself is monitored, scaled, self-healed, etc. And it's increasingly being adopted as a way to deploy lots of other distributed systems. It's not just Cloud Foundry in particular. However, Bosch has been a little challenging to work with in some ways. There was a lot of work that was kind of nicknamed 2.0. We'll describe and I'll explain why it's 2.0, because really it's a format change for one of the manifest files. But a lot of work that was generally clustered together under this tag of 2.0 was intended to dramatically simplify the process of working with Bosch in complex and large environments. So the basic premise was that Bosch has a few different types of artifacts that are brought together in order to instantiate the distributed system and manage it. One of those artifacts is a thing called a release, and that's actually what all of the various Cloud Foundry Foundation project teams are producing as a way to say, this is the software, and then here's actually how you deploy it into an environment. And so here's this thing called a Bosch release. Now that Bosch release is then combined with what's called a deployment manifest. And the deployment manifest says, all of these releases that I might want to bring together, I'm now going to describe how many instances we want to have, what the network topology might look like, which cloud provider I'm going to work with, etc. And it led to some enormous deployment manifest files because there was a lot of redundancy in some of the data that had to be stored there. So 4 key things that got added. First, dynamic IP management. And basically that simplifies the manifest file so you can simply describe the resource that you want, and how many instances you would like and what network you'd want it to be part of. And Bosch, the platform, will actually decide what IP to give each instance. Second, this concept of a global cloud config. So instead of all of the deployment manifests that exist within a particular Bosch controller having to have a lot of the details about the underlying cloud platform that it's working with or infrastructure that it's working with, you can just have that globally established, and that global cloud configuration then applies to all of the deployments within the Bosch controller. Third was first-class support for multi-availability zone job striping. This is a really important feature because in the past you had to actually do the multi-availability zone work by hand as you described your deployment. Now you can just simply tell Bosch to do it for you. And then fourth, there's a number of actual enhancements just based on real-world usage of Bosch deployment manifests, requests from users that were using it to improve the experience a bit. So there's a lot of smaller things that are bundled in there. So what does this give us? Besides the fact that we now have smaller manifest files for deploying Cloud Foundry, there's a really interesting outcome from all of this dynamic provisioning and simplified cloud config, which is that in the past, most Cloud Foundry service brokers that used Bosch as their deployment mechanism would actually have to pre-provision capacity. And then the broker, when an end user, an application owner, asked for a database, it would be either logically segregated or allocated out of what had been deployed previously. When the service broker API was expanded to support asynchronous provisioning, things that might take longer than a few seconds, that opened up the possibility for dynamic provisioning of the actual databases, only consuming infrastructure on demand as new applications are deployed and you need new VMs to host those backend resources. But the second step to making that reality was this dynamic configuration that you can do with Bosch now. So you can expect to see a large number of the existing service brokers that have been created for various backend data systems to be enhanced now to support dynamic provisioning so that they can scale as demand from applications required them. Another note is that this opting into the cloud config or that global cloud config really does require that all of the deployments within a particular Bosch controller start using this manifest v2 format, and that That, by the way, the shift from V1 of the manifest format to V2 is where the 2.0 term came. Very important. And I guess last note, the availability of this is today. These features are now available. They're available as of the Bosch release of Bosch, version 255.4 and up. So those of you that are using Bosch, absolutely spend a minute to go look at some of the new capabilities, consider making the swap. I think you'll find the operational experience much nicer now. Next slide.
Okay, and the last feature that we're going over is elastic clusters. So as we showed you before with Diego, you have a lot of boxes on that picture, each providing different capabilities, right? Some of it is for the logging, some of it's for management, and some of it's for execution. And what elastic clusters allows us to do is it allows us to provide isolated network and compute per organization. Or in some cases you can share them across organizations, but that's up to the operator to decide how they want to slice and dice this. So the whole idea is that we can have a central or common management layer, which is what's shown on the left-hand side, and on the right-hand side we can deploy as many Diego instances as we wish to support the various constituents that we're managing. And so we could have clusters that are shared by all and clusters that are for an individual or an individual organization. Next slide, please.
And with that, I believe we're now able to wrap up and transition to some Q&A. But thank you again to everybody who attended. Hopefully it was useful. Now would be the time to ask us some questions if we can clarify anything for you or talk about anything else Cloud Foundry related.
Great. Thank you, Chip and Michael. It's Tracy again. We do have some questions that came in during the presentation. We'll jump right in. Is Cloud Foundry mainly a platform as a service to build modern web applications, not so much mobile applications?
So I can take that. So if we think about what is a mobile application, really, you know, a mobile application is generally two things. So first, there's the app that's going to exist on the device, whether you're writing an Android application or whether you're writing something for iOS. That has to actually be installed on the device. It flows to the device via the app stores, and Cloud Foundry does not solve for that piece of the puzzle. It's designed specifically for the other part of what makes a mobile application useful. So mobile applications in general, perhaps with a few exceptions, need to connect to back-end services. Now, you could write a mobile application to talk to some existing SaaS-based applications via API over the network. That's fine. Certainly could be useful. But interesting applications that you might author where you need to provide your own back-end capabilities are absolutely supported within Cloud Foundry, because one of the most prominent methods of back-end system access for mobile apps is the HTTP protocol. And in fact, now, if you want to do any TCP-based, even just simple socket-based connectivity into Cloud Foundry, you can do so with the addition of the TCP router. So really, most modern mobile applications are a combination of that native client talking to some web services architecture in the back end. And CF's role in that architecture is to support the web services back end on the in that architecture.
Great, thanks, Chip. Next question, it's on the enterprise references. Are they all using Cloud Foundry from the open source bits that they install and manage themselves, or are they using one of the 9 certified platforms that you mentioned later on?
Yeah, that's absolutely a great question. We have measured this in the Cloud Foundry community and ecosystem, and can tell you that while certainly there are a number of organizations that are choosing to use the open source directly, the overwhelming majority of enterprises that are adopting Cloud Foundry are doing so through one of the vendors, whether it's an online service, whether it's software distribution that's supported by one of the companies, or whether it's part of a larger cloud platform that they're working with.
Okay. Next question is, do you have in future plans data center to data center replication between foundries in your future plan? Data center to data center replication.
Yeah, so that's a tough question to answer because replication of what would be my follow-up. Typically, when you're talking about data center to data center replication, there's really two ways you can look at that within the context of Cloud Foundry. The first way would be to say, is there a way that you can have a multi-data center, multiple Cloud Foundry clusters that might have the same applications, same users, org spaces, et cetera, so that they're identical at that application layer? I've heard that request. It's something that I know that there are some community experiments that are occurring, right? Like I've seen some work where there's a proxy that you would put in front of two different Cloud Foundry controllers that effectively echoes the exact same API calls and keeps two different clusters in sync. That's one part of the puzzle. I believe Elastic Clusters is opening the door to some more complex deployment scenarios that might be also similar to what I just described. It's opening the door to it. It's not solving for it. The other piece of the puzzle, though, is actually the more important piece of the puzzle when you think about your DR strategy, and that's the data on the back end. In general, the Cloud Foundry platform is not a data platform. It has a number of capabilities, specifically Bosch in particular, and a number of great abstractions for how you tie data services to the applications. But depending on the specific database in question, there are going to be different replication approaches that you're going to want to take. So I can give an example of where that's been solved for using Bosch and exposed to the end users. There's the MySQL service broker and Bosch release is actually using MariaDB with Galera clustering, and it's designed to create a high available, across multiple availability zones, a highly available deployment of MySQL that then the applications are tied into. But what's important to understand there is that it has to be written for the particular database technology in question. And so that's a really the key component to how you create good DRs. You have to understand exactly what data store you're talking about, what are its operational characteristics, and then build the release, or actually build the deployment model of that at the Bosch layer to support it. Other providers, with IBM, let's talk about IBM in particular. They offer some online services that are, the availability of that data store is guaranteed based on how they operationalize that database and how they expose that back into users with Linux.
Great. Thanks, Chip. How soon will the new app-to-app communication be there in the Cloud Foundry runtime? And how will lookup be done for each of the microservices in the new networking architecture?
Michael, do you want to take this one, or do you want me to?
I can try. So, like most projects, it'll be ready when it's ready. But to be honest, they've just started. Well, actually, they've been going on for quite some time, and we've made a lot of progress in how we want to expose this. So there's still some more experimentation on exactly how this is going to actually be exposed as a usable function to the end user. We know there are requirements like the ability to have discovery, and much like other platform providers, there's a variety of ways that it can be offered, either through DNS or through local Etsy host rewriting. Again, not all of this has been fully thought out, but it's definitely on the radar as to something that needs to be solved in order to make this usable for applications to go forward.
Okay, thanks. Looks like we have a couple more minutes, a couple more questions, so we're making good time. The next question is, Diego's support of network or persistence looks good. If we are deploying Docker apps to Diego, how does Docker network and volumes translate to the new network that Diego provides? Sorry, I might have jumbled that a little bit. Would you like me to repeat that?
No, that's fine. So while Cloud Foundry supports Docker, it supports the Docker image format, not necessarily all the constructs that Docker exposes, like networking and volumes. While we could try and figure out how to make some of that work as our own support for networking and volume comes along, the way that Cloud Foundry is approaching volumes is slightly different than the way Docker and its like has actually done it to date. And so I doubt we'll be able to get a good match on how that works. Remember in the example that Chip went through, volumes are being exposed as a service through Cloud Foundry rather than just something that's specified either on the Docker command line or in your Docker file as to mount this thing in my Docker container. So with Docker, there's already the assumption that there's something pre-done on my system, and given a platform, we can't make assumptions like that. A lot of that has to be provided to us, which is why we went down a slightly different road with dealing with services as a way to do volume mounting. Networking obviously is similar. However, we might be able to get more alignment there, although even with networking, our ideas are slightly different because in the Docker world, the networking is all exposed to a common networking platform or networking layer. And with Cloud Foundry, what we're doing is we're separating what gets exposed outward as client access, which for us is just over HTTP, or if you're using TCP routing. Anything else is really for app-to-app communication. Now, one could envision that we could, in the future, although I haven't seen the requirement, we could take some of the ports that get defined in a Docker file and actually push that through the TCP routing world. That is a possibility. However, devil's in the details, and some of what we do for Cloud Foundry to make TCP routing work is that we require you to reserve ports. And so it would have to, one could imagine that as part of pushing a Docker application or a Docker file as your application, you could now wire in the whole acquiring TCP ports as part of your process for deploying an application.
Great. Thanks, Michael. And thank you, everyone on the call. We're about a minute shy, so I guess we'll end here. It looks like we answered pretty much all of the questions. Any others, we can address them afterwards, so it's no problem. Again, the presentation and recording will be out momentarily on the Cloud Council website, our events page. And I'd like to invite everyone on today's call, to become a member of the CSCC if you're not already, and please join us for future events. Chip and Michael, we'd love to have you back sometime. And that's all. Everybody have a great day. Thanks.